more log equations. Yeah, you'll see how this comes into play here. Let me get my colors. So it says their logarithmic equations includes one or more logarithms involving a variable. So a log with some variable is going to be included in what we're doing. You're going to take these and you're going to rewrite them in exponential form because we know what to do with them in exponential form, right? So if you see this, how could you rewrite that exponentially? It starts with a 2. 2 to, yeah, what power? What's our what right now? 2 to the x equals what? 8, right? 2 to the x power equals that big number, your 8. So that's what we're going to be doing today, is we're going to be doing a lot of that and using kind of the properties that we've learned along the way. So here are your steps, okay? Just like yesterday, you need to isolate. Now we're isolating the log, okay? Then once we've isolated, then we're going to use some of these properties that we've done. Remember, whenever you see addition, you should be thinking multiplication. When you see subtraction, you should be thinking division. And when you see an exponent, you should be thinking move it out in front like that. Okay? Yes, ma'am.
I was just going to say, like, what helps me remember how the addition is multiplication is it's like the plus is turned sideways and then...
Oh, yeah. A plus.
Like the middle of the dividing line.
Yes, I like that. This is the subtraction symbol and the division symbol, right? Okay, so whatever method works for you, run with it, okay? Here's what we're doing. And then you're going to, rewrite it in exponential form once you've done all of that. So the first thing we need to do is isolate the log, okay? So the log of something needs to be all that is left on one side of our equation. Is our log isolated right now? It actually is. I get why you don't think it is, but because they put parentheses around it, they're saying the log of this whole thing, right? So those parentheses tell us, yep, our log is isolated. So step 1 is done for us. Step 2 is use our properties to combine. Do you see any exponents? No, so we don't need to do that. We don't want to expand here. So yes, there's subtraction, but we're not going to turn that into division right now. We want to turn this into log form, or into exponential form, and then solve for x. Okay, so these parentheses mean we're taking the log of the whole thing, go from there. Okay, so it has been isolated. We don't have any properties that we need to do right now. To turn this into exponential form, what would that look like? What's your base right now? What's here? It's a 10, right? So when there's no 10 there, we assume a 10, okay? You would say 10 to what? To the second power equals what? 4x minus 3. Now this is very simple algebra. What do? Solve for x. 100 equals 4x minus 3, so add the 3. And you get 103 equals 4x, and divide by 4. So x comes out to 25.75. Can I show you something real fast? A really simple way to check that you did the right thing. If you plug this into your calculator exactly how you see it, log parenthesis 4 times 25.75 minus 3 and hit enter, what should you get? 2. If you don't, it's wrong, right? So you can always plug it back in using that log button on your calculator to check if you got the right thing, okay? questions on that? Okay, now I want you to look at letter B. Nearly identical to letter A. What is the difference? Parentheses, okay? So this is saying, this one over here is saying take the log of 4x minus 3. What do you suppose we're taking the log of on B? 4x, okay? This is saying the log of 4x and then take away 3. So is this one isolated? No. What do we have to do to isolate? Add the 3. Okay, so on this one, you're going to add 3. So you get log 4x equals 5. Now you've isolated, okay? There is nothing that we need to simplify with our properties right now because you can already put this into exponential form as you see it. What is the exponential form going to look like here? Yes, 10 to the 5th power equals 4x. If you don't know what 10 to the 5th power is, well, one of two things. It's a 1 with 5 zeros behind it, or you can plug it into your calculator. 10 to the 5th, you will get 100,000 equals 4x, and then you just need to divide by 4. So x is 25,000. Okay, and again, if you plug it into your calculator, this time without the parentheses, the log of, well, you might have to put parentheses around this actually when you plug it in. The log of 4 times 25,000 and then minus 3, you should get 2. Okay? Okay, look at letter C. Is this isolated? What do we need to do to isolate the log? Divide by 4. We want to get this 4 out in front, out of there. So it's the log of 4x equals, I would reduce that to 1/2. What's your next step? Right, write it in exponential form. So it's 10 to the 1/2 power equals 4x. This one's going to come out to a funky decimal. So 10 to the 1/2 power is 3.162, 23 equals 4x. Okay, and then you would divide by 4. So x is 0.7906. If you plug this back in to check it, just remember you've rounded here. So when you plug it back in, it's going to be like 1.99, not exact. Actually, is it? Let me see. 4 log 4 times 0.7906. Yeah, so you get 2.000067205. That's very close to 2. The only reason you have multiple things behind it is because you rounded. So as long as it's so close like that, you're okay, because we rounded, okay? Questions on those? Put it into exponential form, right? Okay, these ones, you have to do the work first, and then you can put it into the exponential form. So we do have to do a little bit of simplifying here. What does this become for us? Addition becomes multiplication. So the idea is simplify it to a single log and then put it into exponential form, okay? So this would become the log of what? 8x. How do you write that in exponential form? Right, you have this little 10 here. So it's 10 to the third power equals 8x. And then you solve for x. Plug in 10 to the third in your calculator if you don't remember what 10 to the third is, okay? We have calculators for a reason. Use it. 10 to the third is 1,000. So you're just going to divide by 8. And 1,000 divided by 8 is 125. Okay? Again, you could plug that into your calculator. The log of 125, enter parentheses, plus log 8, and you should get 3. Okay? So check your work if you're not sure. Okay, try letter B. Log 5 minus log 2x equals 2. What is this subtraction going to do? Division. So make that one log and then solve for x.
This one? So the x should be down here with the 2. So keep the x on the bottom. We're just going to change that. So right from there. So it should be division. So this will be the log of 5 over 2x. So 5 here divided by 2. Instead of a 10x, because it's subtraction. Oh, you multiplied it, right? Yeah, so if that was addition, that's how you do it. So 5 over the 2x. Okay. Make sure your x is your denominator there.
How we doing? This one looks like it's a little bit of a struggle. How do you set this up? If it's division with a single log, the log of 5 divided by 2x equals 2. Now what?
Divide.
We're not actually going to divide it. Zach. Oh, you're trying to get the 5 out of there. We're going to set it up exponentially first, and then eventually we'll do a little bit more of the rearranging like that. What's your exponential form from here?
Squared equals 5 over 2.
10 squared, 10 to the second power, right? Here's your 10 to the second power equals 5 over 2x. So this is 100 equals 5 over 2x. It's up to you how you want to see this. I feel like some people see it easier if you make it a proportion and then you cross multiply. You don't have to. Technically, all you're really doing is multiplying by 2x on both sides. But if you like it better like this, you can totally do it. So this would be 200x equals 5. So then you would divide by 200. So x equals, plug that into your calculator, or if you want to reduce it, you could reduce it as a fraction too. I just plugged it in. It would be 0.025. Does that make sense? So if your x is in the denominator, you have to get it out of the denominator by multiplying. Or cross multiplying if you like that better. Does that make sense? I don't feel real confident right now that you're confident in this. We're okay? Another one? Let's look at this one. This one's similar. What do you do with this one? you multiply, okay? Addition is going to give us multiplication. So this is going to be the log of what? 10x. 2x times 5. So 10x equals 5. How do you put that into exponential form? Yes. This little 10 here, okay, so 10 to the 5th power equals 10x. So 100,000 equals 10x, and then divide by 10, and you get x equals 10,000. Okay, so simplify the log first, get it down to one log. Once you have it down to one log, then you can put it into exponential form. Okay, if you've checked out on me, this is where I really need you to check back in. These last two have just an extra little something that makes them a little bit trickier than all the rest. Let's take a look. What do you see here that needs to happen? Huh. Okay. I see why you say that. But the rules of PEMDAS say we can't, right? Because we have to divide this whole thing by 2. So you would have to divide this by 2 also, which is going to give you really ugly fraction funky things. So I get why you think that.
Oh, so you have to
But we can't yet.
first.
You what?
You have to divide them first.
Division.
And then
But what happens when there's a number right in front of a log? You make it an exponent, okay? So we're going to take this 2, and we're going to move it over here. So this is log base 5 of x squared minus log base 5 of 3 equals 4. Now what do we do? Now we divide. Okay, that subtraction is going to be division. So this is log base 5 of x squared over 3 equals 4. Wow, that's loud. What's your next step? We made it one log. What do? Now exponential, okay? So now what we're going to do is we're going to take this 5, take it to what power? The 4th power equals x squared over 3. Okay, 5 to the 4th, if you work that out, is 625 equals x squared over 3.
and you multiply by 3, then with the square root of it.
There you go. So you're going to multiply by 3. Okay, multiply by 3, multiply by 3. So you get 1875 equals x squared. What happens when you square root both sides of an equation?
Plus or minus.
Plus or minus, okay? So if we square root this, you get x is plus or minus. This comes out to 43.3, we'll say. Here's where you're going to love me. Look at the original problem and look at your answers. What's the issue?
Doesn't make sense.
You cannot take the log of
The negative.
a negative, okay? So while this is your two answers, negative 43.3 is extraneous because you cannot take the log. So really what ends up happening is it benefits you to forget the plus or minus because the negative one here doesn't work, okay? Even though technically you get that. So your answer is just 43.3, okay? Because you cannot take the log of a negative number, and that's what it would require if you plugged in a negative right there. right? 2 times the log of a negative 43.3. Doesn't work.
So on the last page, question, or letter C,
The-
how come we didn't put that into, like an exponent?
Do you try?
On the last
This
page?
C,
You got left in there, do you get little what's in there?
this C.
Yeah.
Because there's no, like back behind that 4, there's no addition and subtraction happening, right? If we're gonna divide by, we can divide by 4 when it's just multiplication happening, but when there's a plus or a minus something, then we can't, because then that doesn't follow the rules of PEMDAS. Yeah, no, that's a great question. Okay, last one. You're gonna love me even more here. On such a loving day. Isn't this great? You're gonna love this. What do? What is this gonna tell us to do? To multiply. Okay.
Like distribute to X.
So you're saying the log of x times x minus 3, right? We're multiplying that x and that x minus 3. When we do that, you can set it up right now, equals 1. You can set it up right now if you want an exponential form. That's probably what I would do. Let's just do that. Your base is what? Log base 10. Okay, so if there's nothing there, it's a 10. So we're going to say 10 to what power? The first equals x times x minus 3. Okay, we're trying to solve for x. So technically right here, your best bet is distribute and say 10 equals x squared minus 3x. How do you solve for x in this situation? Take it way back. Take it way, way back. First semester. Set it equal to 0. Let's see who gets it first. What do you do with something like this? It's a quadratic. You could do the quadratic formula. Do we like the quadratic formula? No, but you could. You could do the quadratic formula right now and you will get there. Factor it. Let's factor it. Good to go, Bella. How do you factor that? Star. See? You're not ready to give up, Grant.
Hanging on by a thread.
Okay, so if we do star method, do you remember what goes on top here?
1. 10.
Negative 10 on top, negative 3 on bottom. Your A term is 1, right? That's this number 1 out in front. What can you multiply to get a negative 10 that you can add to get a negative 3?
Negative 5.
Negative 5, positive 2. So that is x minus 5, x plus 2 equals 0. So what is x?
Oh. That was the dog.
5 and negative 2. Okay, go back to your original. Which one's extraneous? Negative 2. You cannot have a negative 2 because you cannot take the log of negative 2, right? So your answer is x equals 5. So fun. Do you love me right now? Yes, you do. You do.